migrations of fishes, and all of the rules that govern how these variables interact is what we use to evaluate how these components will respond to changes in flows. There is a lot more information about the approach, but I just wanted to show at this point that we do use this Bayesian network probability modeling tool to then provide the probable risk distribution. And you see these blue nodes is what we're looking for, is to get an understanding of the risk distributions for each of the scenarios that we're testing based on what we know in the system, our understanding of the ecology of the system. Okay, so I wanted then to move on to how it works and what have we actually done. So what we do is, I saw a comment now quickly in the chat box to ask, why did we consider the pre-1960 to the post-1960 period as in this testing, the dry and the wet phase? And these two graphs here, these are box and whisker plots of the discharge, the flows that have been recorded in the Sudd from 1905 to 1960, and then from 1960 to the late 1980s. And what you can see in terms of the levels and and I've used the 20th and the 80th percentiles for my boxes, you can see that there's a noticeable difference between the flows pre-1960 compared to post-1960. So we consider this to be a drier period where we have observed data pertaining to a naturally drier phase in the area compared to post-1960 in a wetter phase. And I was very interested to hear that there's been even greater flows observed recently being released from the now Lake Victoria. So that would be very interesting. So what we've done in this study is, in order to understand, we have some idea of how the ecosystem and or the physical attributes and the ecosystem, the indicators of the ecosystem interact. And what we also know was that prior to 1960, during this drier period, which would have been more of a critical period from a reduced flows perspective, that represents the Sudd's natural state. In other words, it has been observed, the Sudd has been able to deal with these type of flows. So if we base our understanding of what the Sudd has been able to withstand, we can use this as a baseline period. And that's what we did. So we know that pre-1960, we have from the modeling some idea of what habitats were available. I'm going to get to that in a moment as well. And we have an idea then based on habitat availability, what the ecosystem may have looked like and some of the processes. And we can now compare the post-1960 period to the pre-1960 period and see how the ecosystem may have changed. And we also have a range of scenarios to consider to compare how any of those alteration scenarios, development opportunity scenarios, for example, that we've looked at previously, could have affected the environment. And that's what we've used to determine what the socio-ecological consequences of environmental flows, of altered flows has been. And that has then allowed us to establish what the environmental flows that are required to maintain the ecosystem in a suitable condition are. Okay, so that's in a nutshell what we've done. And I'm sorry, there's quite a lot of information, but I just wanted to get you guys to the point where you can understand what we did in this case study. So what I have here, in addition to the hydrological scenarios for pre-1960 to post-1960, I've also included what Jens mentioned, is the flow variability for all of the options that they provided to us based on the hydrodynamic modeling. And just look at the scales, for example. So we have some exceptionally higher flows relative to what's been observed and some extremely low flows. And then what we were able to do, because we had the model available to us, was we were able to use the data to relate it to habitat availability. And you can see that this is now a box and whisker plot looking at the relationship between discharge and the availability of habitats, inundated habitats that are between 0 and 0.1 meter. And this is greater than 1 meter to 0.5 and from 0.5 to 1 meter depth. So you can see in relation to the discharge of flows, we are able to look at the probability or the area now of habitats available in the Sudd. And that's really been a breakthrough for us, because when we're dealing with the environmental flows for a wetland like the Sudd, we're dealing with the entire ecosystem. So we're not looking at a site on a river, and we're not considering the whole river. We're only looking at a site. We're dealing with the entire wetland. And that's why we needed to, that was some of the important outcomes of the work we did in the Inner Niger Delta, was that you have to take a more quantitative approach to looking at the changes in how much habitat is available and what the implications may be. So that's what we did. Then from the hydrodynamic model, this was quite interesting. We were able to look at relationships between discharge and the area of habitat where we had an average depth of water of less than 5 meters. It's actually approximately 0.5 meters in depth. Sorry, that square shouldn't be there. Please excuse that. And then 1.5 meters depth, 1 meter depth, and 2 meter depth. Please don't be misled by that square. And what we found was that when you're looking at these very shallow depths, the relationship that we had between inundation area and discharge were very weak. We had almost no relationship between inundation area and discharge. But as you go deeper, you can see that there is a clear relationship and a nice relationship between the discharge coming into the wetland and the availability of that particular depth. And I just wanted to show you, this is another example of just organizing the data to show that we could sort all the data from the highest discharge to the lowest discharge and relate that to different depths. And interestingly, you can see that, which makes perfect sense, that because you're dealing with a dynamic wetland with lots of control areas, that the inundation we don't just flood and inundate the entire wetland. Then the wetland inundates in different patterns. Some parts of the wetland are inundated before others, and then there's a control and the water gets deep and then it flows into another area. So you can see the actual topography would then influence some of these strange shapes of the relationships between discharge and inundated habitat. And over here, I've just plotted the R² values. So this gives us an indication of how accurate our relationships are. And you can see that there's a nice clear relationship between inundation levels of between 1.5 meters and about 6 meters. And then anything deeper than 6 meters starts to get very sketchy again. The uncertainty goes up. We're not very reliable relationships. And in those very shallow areas, we also have issues with reliable relationships. And one of the major issues pertaining to this was that, if I can quickly go back to this graph, is you can see that these very shallow habitats actually represent the majority, the largest portion of the wetland. Okay, so that was a concern of ours. Nevertheless, I'm going to come back to that in a moment. Nevertheless, from some of the other work that was done in the study area, this was work done by James Mackenzie, we had some understanding of the relationship between the depth and the duration of habitats and what type of habitats would probably occur based on how long those habitats were inundated and how deep those habitats were. So James Mackenzie was able to give us some understanding of what the probable habitats would be if you had a different depths of between 0 and 3 meters of water within the wetland, across the wetland, and how long, how durable those habitats were. And what I did here is I took this distribution table and I converted it into a weighting table. You can see here, if you look at the frequency of open water, for example, you can see that you will most probably, if you have habitats of 2.5 meters or deeper, you will most probably end up with open water habitats. And we were able then to work out what was the probable range where you start to find these different habitats and when you are more likely to have these type of habitats. So that's all I wanted to do here, is I want to determine from our hydrodynamic model and our understanding of the relationship between the hydrodynamic model and the water levels in the wetland, what type of habitats would probably occur in different parts of the wetland. Could I model that? And could I use that area to give me some understanding of the consequences of altered flows? And we were able to do that. So you can see here, for example, for papyrus, when the depth of water, you can get papyrus at any depth, but when the water exceeds about 0.25 meters depth up to about 1.75, and the duration is high, you will probably have papyrus habitats. And you can see that there's some overlap, but there is also some indication of what habitats you may achieve. So what I was able to do then is determine the zero, low, moderate, high thresholds as to when you would expect to find or not find a particular habitat type. So I wanted to determine, based on the depth, first of all, at what depth would you probably find a particular type of habitat? Because again, as I showed you from our model, that's what's driving the ecosystem in this case study. That's what we, based on our understanding, that was what was available to us. But then I was able to convert these depths based on our relationship graphs. You can see these graphs here into a discharge. So now I'm able to understand what discharge will provide me with a particular depth distribution in the habitat in the wetland, and based on that depth distribution, what type of habitat would be available, and that was all based on upstream discharge entering the wetland, and that's what we needed to do. So we put that information. Sorry, I know it's quite fast. We took all of that information. We used that information to build our probability model and understand how different attributes of the ecosystem will respond to availability or non-availability of habitats. And that is in our risk assessment. And then what I did is I queried all of the available flow scenarios that were available to us to give us an understanding of what is the probable risk of those endpoints being achieved or not achieved. Okay, so that's what I'm going to show you now. So now moving on to some of the outcomes of the study. So this is the first one. So the first thing I wanted to show you was this blue graph. First over here. Yes?
You're doing time, so you may need to wind up, please.
Pardon, sorry?
You may need to wind up now, please.
Okay, I'll just speed up quickly. So when we looked at all of the scenarios that were available to us, you can see that the risk distribution, if you look at the blue, green, yellow, and red, it's from no risk, it's related to natural, moderate, low, moderate, and high risk. If we have any of these standard deviation bars going into the red here, you know that scenario is probably going to result in failures of some of these endpoints, fisheries, grazing. And you can see from some of the initial assessments, we showed that whatever we did, it was very difficult to end up with extremely high risk. And this is one example here where the scenario, I'm just trying to make sure that it's the green one over here. For year 2, option 7, year 2, looking at September month as an indicator month in particular, we would get into an unacceptable high flows. What we realized then, and it was similar for all the other scenarios that were provided for by Jens's modeling team to look at the extreme variability, we did find some scenarios that were completely unacceptable, and we were able also to demonstrate what scenarios were acceptable. But one thing we found was that we were very surprised at how resilient or tolerant the ecosystem seems to be based on the pre-1961 distribution of habitats to all of these different scenarios that were provided in the case study. Then we realized that we went back to the team to discuss some of the outcomes, and we realized that one of the biggest potential areas of uncertainty that are affecting those initial outcomes was the fact that the model incorporates general rainfall, precipitation into the availability of habitats. And that's probably why we have such a bad correlation between the shallow depths and the discharge coming into the wetland. So we tested it. We tested to say, well, let's take out all of the contribution of rainfall into the availability of habitats in the wetland. And that we related back to the input flows as input flows. So this is an example now of the same options that were provided to us by the Hydroc team of input into the wetland. This is discharge. You can look up to 4,500 cubics, and this is the median percentile. This is the 50th percentile. And if you can look at that compared to with rainfall and without rainfall, there's a significant difference. And if you look at the consequences, if I on the left-hand side have with rainfall and the right-hand side don't have rainfall, then you can see immediately the wetland becomes totally unacceptable. You know, then most of the scenarios are exceeding, moving to, there's a high probability of high risk, which means that we're going to lose social and ecological endpoints. And I think what's really useful here, and this is what we've discovered, and this is what led us to the establishment of environmental flows for the Sudd wetland, was that we know that historically rainfall has been a contribution and will always be a contribution to the availability of habitats in the Sudd wetland. And we can actually use that relationship between input flows and rainfall to give us some indication of what the normal period, normal conditions, during a normal wet phase or a dry phase, what should the input flows be to complement that rainfall? But then in a climate change scenario where you think that you may have severely or significantly altered rainfall, we actually have some data to demonstrate what the consequences will be when you're depending on the upstream flows into the Sudd wetland alone. So the outcome of the whole study was to present these different types of flow duration tables that represent environmental flows for input into the Sudd wetland that is complementing available rainfall to maintain the habitats in the Sudd wetland in a sustainable state. And this was done again using PropFlow. So I'm sorry, this was quite a lot of information in a very short period of time, but it's been a wonderful opportunity and experience to be able to do this and solve some of these problems. And I apologize, the report has been very late because of these issues that we've discovered, but it should be done any day now. Thank you very much. Okay, bye.
Thank you, Gordon, for that great presentation. There's a quick question, please. There's a quick question for you in terms of, could you please tell us what is your reference for this information regarding to vegetation, animals, etc.?
Brilliant. That is so important. So what we do is we use the pre-1960, we use the hydrodynamic model to give us an understanding of what was the habitat availability in the wetland pre-1960. And based on the availability of habitats pre-1960, we were able to use some of the known ecological data from the wetland to then give an estimate of what was available in the dry phase pre-1960. And that is what we used as our reference. That is what we used as our baseline. So we compared all of the changes to that, the availability of habitats and associated ecosystem in the wetland pre-1960, and that was all modeled. We need more data. If I could advise anybody going forward to reduce uncertainty and to get a much better understanding of the management of the system and what the consequences of altered flows are to the Sudd, we need more hard evidence of what's happening in that system.
Thank you for that response. I will now call Paul Dimitri to give us a final presentation in terms of where we are moving to with the Sudd action plan. Paul, please.
Thank you.
Yeah, thank you. Thank you very much, Leonard. You can share the screen. You want me to share from my side?
Okay, please, if you can. Gordon, you have stopped sharing yours, I think.
Yes, I've stopped.
Okay. So Dimitri, try sharing from your side. Or
Let me do that.
no, let me share. It's here.
Okay.
I've got it. Okay. Okay.
Welcome, colleagues, once again.
Just your volume, please. And you have like less than 10 minutes, please, to share this. Thank you.
It'll not take me long. Yeah. All right. Welcome.
Okay. Yes, go ahead. Hello. Hello.
Oh, sorry, my internet decided to go off.
Okay, please go ahead now.
Yes. So after having had the presentations from the Hydro colleagues who did a number of studies, it came out very clear that there's a lot of gaps in terms of the data that we need to see. Leonard, you can put it in presentation mode.
Yes.
All right. So we need to look into the next steps in terms of the strategy. So what strategy do we need to take for us to conserve this particular wetland? And looking at also the different stakeholders that we have there and the next steps that we are taking with MBI. So next. So this particular presentation, I'm also doing it on behalf of my colleague from the Ministry of Water Resources, that is Francis, who is also a member of the regional working group together with us. So we'll look at the conservation strategy. We started that through a workshop in Juba, which was done in March last year, almost a year. And we brought on board a number of stakeholders from the country to be able to look at how do we now go from there. So in terms of the action planning, the conservation action planning, which is supposed to provide a roadmap for us to head to in terms of the strategies and action for the Sudd wetland. What is it that we need to do as stakeholders within this particular wetland? So we looked at who are the critical stakeholders, looking at them in terms of their stake within the wetland, and then defining also the scope and the strategic conservation targets that we need to look into, and then also the situation analysis and the context and the critical threats, classifying even the threats. And then the last thing is to develop strategies and measures that we will have to now implement through adaptive management, and then mobilize resources in terms of the implementation of the strategy, and then we do monitoring and learning process. Next. Now, in regards to the stakeholder processes, this is still ongoing, but it was started through the first meeting that we had together with the regional working group members. And then there is the development of the process of the Sudd wetland management plan, which was also facilitated by the same group. So this is ongoing. Next. Now, looking at the different stakeholders, first we try to open up also the wetland working group members within the country. So we have the wetland departments from the Ministry of Environment and Forestry. We have colleagues there. And then we also have the representative from Mashar Masses, especially from the local government and the right departments at the subnational level. And then we also have the representative from the right local government institution around the Sudd wetland, especially around the states that are surrounding the Sudd. We, from academia, also University of Juba, especially relevant departments to the Sudd wetland management. And there's also from the Upper Nile University, and also Nile Discourse Forum, and then from the Ministries of Agriculture and Food Security. We also have, this is an indicative list which can be expanded. We have also livestock and fisheries. We have environment and forestry. We have energy and dams, wildlife conservation and tourism, land, housing, and urban development. We have humanitarian affairs and disaster management. And then we have so many other state and non-state actors that are with us in the group. Now, what is the next steps in terms of the action planning or the strategy development? So the Sudd Wetlands Conservation Action Planning at the moment is ongoing. The scope, target, and stakeholder mapping is already done, and the situation analysis is still ongoing, and the stakeholder consultations that are supposed to take place is also ongoing at the moment, and then the action planning is also going. So for some of you who are very familiar with strategic planning, this is the steps that we are taking. And then we look forward to having you join us, and also those who are able to also support the process so that we're able to conserve this beautiful wetland. Thank you very much, and back to you, Leonard.
Thank you. Thank you so much. Thank you so much, Dimitri, for sharing about what is happening with regards to the action plan. I think from the first presenters, which was Paul and Juan Carlos, we get the feeling of the challenges that are facing wetlands in South Sudan, and more specifically the challenges that are facing Sudd wetlands, whether it is extractive industries, whether it is the livelihoods which are going on, and of course the ever-present challenge of resumption of Jonglei Canal. And of course, from the three presenters from Hydroc, we really get to understand both from the model and the environmental flows issues, the dynamics that are occurring in Sudd wetlands, and of course also from the inventory, we also get how rich the Sudd is in terms of biodiversity, in terms of water resources, and other ecosystems, services and goods. So with this kind of knowledge base, and then we really need to move on into that level of action planning, mobilizing resources, developing targets, and moving forward towards the conservation of Sudd wetland and also the wetlands of South Sudan. So with that kind of presentation and summaries with regards to the action plan, then we come to the end of today's webinar, which was a special focus seminar on the South Sudan wetlands with reference to the Sudd wetland. I urge you to join webinar tomorrow, which will delve more into the issues of environmental flows, which has been shared with Gordon with respect to Sudd, but more on environmental flows will be there in the webinar for tomorrow, scheduled at 2 p.m. So I urge you to join the webinar tomorrow, and also thank you for joining this webinar today. And most of the questions you have asked, I've seen our panelists respond to them. So without much ado, I thank you for joining us, and we look forward to you joining us again tomorrow at 2 p.m. for the webinar on environmental flows. Thank you so much, and bye-bye.
Bye, everybody. Have a good day. Bye-bye, everybody.
Bye-bye.